Let's see how to create an ETL job in AWS Glue Studio. So, as we know, AWS Glue Studio is an extract, transform, and load platform, and it gives us a lot of functionalities to load data from various sources. It can be from a database, it can be from any repository like S3 bucket. So it's really helpful for us to understand how the data would look like from the source and then transform it based on the use case or the requirement onto a specific format. So this data transformation can be done from more than one sources and then load the data, that is the transform data, onto a target system. So in AWS Glue, there are two different components that forms or that facilitates the creation of an ETL job. So the first thing is the data catalog, and the next thing is the job itself. So as you see here, the data catalog consists of a connection, a crawler, and a database. Now, a connection is where you'll have to go and create new connections onto the Glue catalog, data catalog, and it helps us to load all the data through this connection onto the databases that we define here. So let's look at it from a step-by-step process. So in the data catalog, all that you need to do is create a connection. So in this particular scenario that I've used, a use case wherein we are trying to analyze the data from two different sources. So the first one is a SQL Server connection that is from an AWS RDS system. And then the second source is from an S3 bucket where there is a CSV file. And we would use the data from both these systems and just do a comparison and then transform the data and load it onto a new location, probably another S3, or it can be loaded onto another database or to an AWS Redshift. Now, the connection that you see here, these two are the sample connections that I've already created. So I'll just click on the JDBC connection and it gives you details on the driver path. The driver path is automatically picked up by AWS Glue. The connection URL is the main thing that we need to specify. So I've created a sample metadata database in RDS, and that's the URL that you see there. It's a SQL Server database, and that's what you see there. So likewise, once the connection has been created, you can also test the connection and ensure that it's successful. And once you do that, you'll have to go and create a database in the data catalog section. So as you see here, there are three different databases that I've created. The one that I need for SQL database is here. So let me just edit it and show you the options that we need to provide. All that you need to give for this database is a name, and the table can be specified for these databases that you create, or when you actually create the crawler and run them, it generates these tables in the runtime. So these are the tables that has already been loaded based on the crawler that I've created and I've already run. So that's the SQL database. Similarly, I've created a database to load the S3 data, the CSV data, and I've also created a sample target database. Now, this is something that I'm not going to use for this particular use case, but it's just for you to hold the data within your within your ETL job. Like when you create your ETL job through the visual ETL UI, you can use this data catalog for storing any data on a temporary basis or just before your transformation. I'll move on to the crawlers. As you see here, there are two crawlers that I've created. The first one is an SQL crawler. So I'm just going to edit it and show you the options that needs to be provided for creating a crawler. So give a specific name, and all the characters needs to be in lowercase. and make sure it's unique across the subscription. So the data source needs to be specified here. So the data source I've given here, since it's a SQL crawler, I've selected a JDBC, and this JDBC is an existing RDS database that I've already created in the connection. So all that you need to do is just select whichever connection needs to be used for this, and then include a path for it as well. So then this crawler will load the data from the SQL Server database that I've already, the connection that I've already established. Now you also need to give an IAM role. So I've created a sample glue role. This role will ensure that all the ETL jobs that needs to be run across, say for example, if it's S3, then you need to assign those specific permissions onto this role. If you're going to work with SQL, then you'll have to add those specific permissions onto this role. So this is something that you create in your IAM role. I can quickly show you how it looks like for these roles. So the role I've created is sample glue role. And if you see here, these are the permissions that I've assigned to this role. So I need an AWS Glue console full access. And then I also need the SageMaker. I would need the S3 full access, RDS full access, and also the Glue service role. So all this can be assigned here, and this role can be used for running the ETL job. So there are few places where this role is necessary. Whenever you want to run a crawler, you need the IAM role. And then whenever you need to preview the data in your ETL job, I'll just show you in a minute, you would need the IAM role. And then you would also need this role to execute your ETL job, that is to run your ETL job. So once you specify it, it's just specify once and it just remains there for the next consecutive runs of the jobs. So I'll click on the next button. And then there is an option for us to schedule this crawler. So it can be on demand, or it can be set up on an hourly, daily, weekly, or monthly basis. Or you can even create your own custom schedule. Like, for example, if you want the crawler to run only during the weekend on a specific time, but not on any other days, then you can create your own custom scheduler and select that frequency here. So once you click on next again, so you'll have all the settings that we've already selected. And I'm just going to click on an update. But if you're going to create a new one, you'll just have to create crawler there. So once that is done, you run the crawler. So I've already run this crawler few minutes back, but I'm just running it again just to ensure or show you how it looks like. So while this crawler runs, let me go ahead and show you the other crawler for S3 and how it is different from the SQL crawler. So here for the S3 crawler, the difference that exists here is the data source. So as you see here, this is not a SQL Server connection, but a direct data source connection onto the S3 bucket. So you select your data source here. So I've selected S3, and then you have to give the complete S3 path. Now, I'll show you how the file exists within this S3 location. So this is my file, customers.csv, and this is the path. So I've saved it in the sample document S3 under the sample folder, and this is how the data looks like. So I'm just loading some sample customer data. So this is all sample ones. It's not real data. It's generated one through a tool. And so as you see here, my main interest is on the customer ID, which we would be using to make a join between this particular file, the data that exists in this file, and the SQL database. So let me also show you the data within the SQL database. I've used Azure Data Studio to connect to the SQL Server RDS. And the one that I'm interested in is the customers table. Sorry, the documents table. So I've got the customers detail in the CSV file. Now I've stored some document details which consists of file names, a document file name, a file path, a document type, and all this is related through the customer ID. So what I'm trying to do is I'm trying to get the data from the schema, from the SQL Server, combine it with the data that I just showed you in the CSV file, and load it onto a new system, like another S3 location in a CSV format. So that's my aim. And let's go back to the crawler here. So ideally, the CSV file is what will be used as a data source for this crawler, which will load it onto the databases once the run is completed. Let's just see if the previous crawl, yeah, this has run just now. Yeah. Oh, sorry, it's still running. Yeah, the last run is at the previous time. So this is still running. So let it run. We've already got the schemas established for this. So I'll show you with the SQL database. So these are the tables that have been created previously when the crawler ran. So as I showed you, the documents table, this is the one that we are interested in. And by default, when you create a connection to a database, it loads all the table into the data catalog, Glue catalog, in a similar way. Like we saw that there are three tables: documents info, and document info. So all these three have been created here as three different tables. I'm just going to select documents and show you the schema. So this is the same as what you see here with the column names. So the same column name has been replicated here in the Glue catalog. So that's with the SQL catalog. And then let me show you the S3 one. So I've given the location for the CSV file, and hence the classification by default shows a CSV. So this table gets updated as soon as the crawler run is completed. So these are all the data that has been created after the run is completed. So I've not made any configuration changes and I've not created any table. This has been created from the run. So let me just show you the schema for this. So it loads by the columns because it's a CSV file. And I think I've closed that file. So in that, if you remember, there were 7 columns in which it had customers' first name, last name, address details. And the last column is where the customer ID was stored. So that's how the data catalog is generated within AWS Glue. Now, the interesting part is creating the jobs, the run job. So I've created a sample job here. And so if you click on this nodes, the node is something like a step in a workflow. So as you see here, there are 2 ways of creating this ETL job. One is through the visual, and the other option is to look at the script and create a script or make changes to this existing script. But once you make change to this, the visual flow will disappear, because the visual flow is more or less like a preset build format. So these nodes are all pre-built. So if you make any changes to the script, the spacing and the configuration of all these preset ones will change, and hence the visual flow will disappear and you'll have only the script. So just be careful whenever you use your visual format and you make changes to a script, because you're not going to get back this workflow again. So as you see here, if you add a node, there are 4 options. So popular is more or less like a recently used ones from your existing nodes that you've created. So the main thing that we need to understand is the source, the transform, and the targets. So under the source, you have different options of using an existing AWS Glue catalog that we've already created here. So for us, as you see, we've used 2 different data catalogs here. So these 2 are the sources. So the name is something that you can specify. I've given it as S3 catalog just for us to understand which system we are referring to. So the database is a sample 3 database, S3 database. This is the Glue catalog database name. If you see here, sample S3 database and sample SQL database. So these are the 2 sources that we saw there in the ETL job. So you have the S3 catalog, and then you have the SQL catalog, which holds the sample SQL database. So there is also a data preview and output schema, but whenever a data preview is run, there are charges associated with it. So since this use case is quite simple, I'm not going to wait until the data preview is generated, but I'll show you the other options in the node, in the creation of the node. So I've determined my sources. Now I'm going to transform this data that I get from both the sources. So what I've used here is a join, but there are few other options within transforms. So you can change a schema. So by changing schema, what I mean is the source that drives the input data to this particular transform step will hold all the field names and data types. So you can drop the fields, or you can change the field names and data types here in change schema. So in join, you have a few options here. So as you see here in the join type, it has inner join, outer join, similar to an SQL join that we write, or the general rule on getting the common data, or if you want to omit the common data and just keep only the data that is in both the source systems, but just remove the common data. So all those operations can be done in this join condition. So you have an inner join, you have a left join, you have a right join, you have an outer join, you also have left semi join, left anti join. So these are the different options in the join format. So I basically need this join because what I'm trying to do here is create a condition for this inner join, make sure I include data from both the systems, but I want to select only the data that matches with a customer ID in both the systems. So if I have a customer ID in the S3, the CSV file that's stored in the S3 bucket, I need only those data that matches with the SQL catalog's customer ID. So that's the condition that I've created here. So you can go ahead and select, I know column 7 is where the customer ID is stored. So I've selected that. And then this is the schema from the SQL database. So I've selected customer ID here. Now add this condition and save the file, the ETL file. So that's one of the options that we saw in the transforms under the join. Now there are a few more options here. You have a SQL query, which I've used in this ETL job. I'll explain it in a minute. And then you also have detect sensitive data. So I think the latest version of AWS Glue has taken into account of highlighting or working with PII data, personal data. So it helps us to identify the sensitive data. It also helps us to evaluate the data quality. That is, it evaluates the quality and completeness of your data, and then fill missing values. So if it finds, if you need to fill any missing values from the data that you're working on, you can do that. You also have an aggregate function. You have a custom transformation where you can create your own custom code to transform data. drop duplicates, drop fields, drop null fields, filter. Filter is a very good option because it's quite easy to use. You just need to filter the data that you need and just leave out the rest. Rename field, a conditional router. This is also good because if you want to specify a condition or an operation like an AND or condition, and if you want to combine those, and then based on those conditions, you want to transfer the data to a different output sources, that can be done using conditional router. And then few more are there. I'm not going to go through all the options that are here. So because my use case is quite simple and I just want to restrict to that. So let's go on to the targets. Or just before we go on to the targets, let me just show you how the SQL query looks like. So it's pretty simple. I've set a node parent. So the arrow marks that you see here in the workflow, it gets generated automatically based on the source that you define for each of these nodes. So for me, for the SQL query, I've selected join so that the data that gets joined here flows into the next box, which is the SQL query. And then the input source will automatically be picked up because it knows that it's getting the data from a join transform step. And then SQL alias is something that you can change. I've just left it as it is as my data source. So the SQL query, the default one is a select star from my data source. So what it means is whatever condition is matched within this join step and the final data that you get from the join. So for example, let me just show you how the output schema would look like from the join. So from the join step, you will see that all the columns from the CSV file is included and all the fields from the database table is also included. So it's a combination of both the S3 source as well as the SQL source. So that's what I wanted to do here, like just combine the data from both the source systems. And so this data, like all the rows that would satisfy this condition here, would flow into the SQL query. So within the data that that gets generated from the join onto SQL query, if I want to select some specific fields and use only those fields, then you can specify it using a SQL query. Like probably you can use like select column 1, comma the first name from the previous output schema that I just showed you. You can just select those alone, but I've just left it as select star from my data source. And so the output file is where I'm sending it as a CSV file onto another S3 location. So this is the target. So I showed you 3 elements in the nodes: a source, a transform, and a target. So target and the source it'll contain all the compatible ones with AWS Glue here. You can also manage the connections from here. So if you see here, you've got MongoDB, Azure Cosmos, a lot of options here. PostgreSQL, MySQL. You can also write the data onto a different Glue data catalog. So that's the reason I created a target database under the data catalog, but I'm not going to use that because I want to write the file onto the S3 bucket. So if you see here, this is the target component, and I've just left the name as Amazon S3. So here the parent node for this will be SQL query. So this arrow mark will automatically get generated. And then the format that I need is CSV. So the other formats that are supported here are JSON, Avro, ORC, Parquet, Apache Hudi, Delta Lake, Apache Iceberg. So these are the other formats that are supported. And then you can also define what type of compression you need to specify for these files, and then provide the target. You can browse through. So there are 2 different S3s that I had created for this use case. So I've selected the sample target here, sample target S3. And there are options to update the data catalog. Like if you do not want to update the data catalog, create a table in the data catalog for this particular step. So all those options are available, but I've just kept it as do not update the data catalog. Add a partition key. So you can specify any of these fields that you have and give a partition key for that, so that separate files are being generated. But I just need only a single file to be generated. And yeah, that's it. That's your target. So once this is done, you save it, save your file, and then run your file. Okay, I've just clicked on the run button now. It says it started the job. It's still running. It takes some time to run. And the way AWS Glue's pricing component is involved is basically for the time the ETL job takes to run. So no resources to manage, no upfront costs. It's not charged for startup or shutdown time. But whenever you generate a data preview, if you remember in the visual format here, whenever you need a data preview, that is chargeable because it actually generates the data over here in each of these um, steps here. So that's chargeable. So just be careful when you create your ETL jobs and when you run them.